Assalamualaikum. My name is Nur Hidayah binti Mat Ghazali. My number matric is 82280310. We are from Group 5. So, we want to present our assignment Business Statistik about number depan of car by liter per 100, weight and kilometer per liter. And then, I want to talk about data description. Business statistic is a method that uses statistics to obtain valuable information from the data available to a company. Various statistical techniques and principles are used to gain insight that help make better decisions. This information can be taken from survey, experiment, or other information system in a company. Widely used approach in business statistics are based on elementary school concepts such as means, mode, and median, bar graph, bell curve, and basic probability. It is based on hypothesis testing, such as test hypothesis, and regression analysis, such as data relating to equation. In data description, the variable of interest refers to a characteristic or attribute that is measured or observed in the dataset. These variables are the building block of data and are the focus of analysis in statistical study and research. The description of these variables usually include information about their types, measurement, scale, and distribution. The purpose of this study is to describe the relevant variable and the various files or features contained in the dataset. The dataset we choose is Set A, which consists of information about the vehicle fuel consumption per 100 kilometers liter per 100, its travel distance, the number of engine cylinder, the total horsepower, its weight, and also the car brand. In terms of measurement unit, we use numerical variables which are important to define the unit used to measure in meter and kilogram. We study vehicle fuel consumption using liter per 100 and weight as independent variable, while distance traveled was the dependent variable. The data show the presence of various car brands, including Mercedes, Audi, BMW, Ford, Honda, Opel, Citroen, and Datsun, which will be discussed in more detail in the following table. We also determine the number of mode, mean, and median in studies using this dataset as class interval. The mode is the value that appear most frequently in the dataset. In a frequency distribution with class interval, the mode is the midpoint of the class interval with the highest frequency. It is even more obvious when the average or mean is a measure of central tendency. For datasets with class interval, one would normally use the midpoint of each class interval as the representative value for that interval. Next, the mean can be calculated by summing all these midpoints multiplied by their respective frequencies and then dividing by the total number of observations. The median is another measure of central tendency and represents the middle value in a data set. And further, we also found quarter 1 and quarter 3 value in this investigation that we did. We used a histogram-like chart as a illustration for our study. Finally, we will analyze the data in section 5 of this study using SPSS software. We will compare the result of manual calculation with another one obtained by using the program SPSF software. Each data that is numerical and graphical data will be compared, and we will use this SPSF software to do ANOVA as a hypothesis test point. At the end of the study, we will discuss whether liter per 100 and weight affect the value of a car or not. That's all from me. Thank you.
My name is Ahmad Nizamuddin bin Zohar, manometric 82280407. For sampling data and category data required, sampling is the process of selecting a group of subject or item to represent a target population sample. Three variables determine sample representativeness: sample size, sample technique, and response. Probability sample is a strategy that matches a point in a dataset to avoid association. Category data is a set of information categorized into groups with type like nominal and ordinal. Sample size effect estimate accuracy and the ability to draw conclusion from the study. For example, the lowest two-digit metric number of Nur Humaira binti Yusri Azli metric is 05. Table 1 from random sample 150 of 393 case by the liter per 100. Table 2 from random sample 150 of 393 case by the weight. Table 3. From random sample 150 of 393 cases by the KPL. For table 4. From random sample 150 of 393 cases by the brand of car. And table 5. From random sample 150 of 393 cases by the brand of car have been automatic record from the sample.
Hi, my name is Nomaira Akila binti Yusi Azli. My metric number is A22A0705. Now I will continue number 3, who is numerical descriptive measure. 3.1 is measure of central tendency. They are mean, median, and mode. For mean formula, sum of all score divided by number of scores. Then, for median formula is lower class boundary of median class plus in parentheses and divide by 2 minus cumulative frequency before median class minus 1 and multiplies class size. Mode formula is lower class boundary of the model class plus in parentheses the difference between frequency of model class and the frequency of the class before model class divided by the difference between frequency of model class and the frequency of the class before model class plus the difference between frequency of model class and the frequency of the class after model class and multiply with class size. We can see here the mean for all categories. Mean for liter per 100 was 6.33, mean for weight was 3.903 kg. Lastly, mean for kilometer per liter was 16.47 km per liter. Mode for liter per 100 was 11.78. Mode for weight was 4.141 kg, while mode for kilometer per liter was 49.17 km per liter. Lastly, for measure of center tendency, which is median, median for liter per 100 was 79.05, median for weight was 21.283 kg, and median for kilometer per liter was 240 and 18 km per liter. We go to 3.2, that is measure of position. In measure of position, we have quarter 1, quarter 3, and interquartile range. Quarter 1 formula a lower class boundary of the quartile class plus in parentheses and divide by 4 minus total frequency of distribution divided by frequency of the quartile class and multiply with class size. Quarter 3 formula a lower class boundary of the quarter class plus in parentheses 3 and divide by 4 minus total frequency of distribution divided by frequency of the quarter class and multiply with class size. Interquartile range formula is quarter 3 minus quarter 1. Quarter 1 for liter per 100 was 41.99. Quarter 3 is 170.28 and interquartile range for liter per 100 was 75.29. Quarter 1 for weight was 12.99 kg. Quarter 3 is 31.58 kg. Interquartile range for weight was 18.59 kg. Quarter 1 for kilometer per liter was 130.38 km. Quarter 3 for kilometer per liter was 314.72 km per liter. Interquartile range for kilometer per liter was 201.34 km per liter. Lastly, we go to 3.3, that is measure of variation. Have two variation, which is sample variance and sample standard deviation. Formula for sample variance is 1 divided by n minus 1 in parentheses sum of frequency power of 2 minus sum of frequency divided by n. Sample standard deviation formula is square root of sample variance and power of 2. Sample variance for liter per 100 was 1.90 and standard deviation was 1.38. Sample variance for weight was 310.69 kg and standard deviation was 17.63 kg. Sample variance for kilometer per liter was 5,309.34 and standard deviation was 72.87. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abdul Selamat. My number is A22B0058. Today I will present 4.0, which is graphical representation. First, in diagram 4.1, which is liter per 100, it can be seen that the interval class between 5.28 to 6.28 equal to the midpoint 5.78 as the highest value, which is 45 frequency. In addition, the interval class between 10.33 to 11.33 equal to the midpoint 10.83 at the lowest value, which is 1 frequency. Next, in figure 4.2, as the weight of each vehicle, it can be seen that the interval class between 3.14 to 3.39 equal to the midpoint of 3.265 as the highest value, which is 39 frequencies. In addition, the interval class between 4.897 to 5.147 equal to the midpoint of 5.022 as the lowest value, which is seed frequencies. Figure 4.3 show the kilometer per liter. It can be seen that the interval class between 14.44 to 17.15 equal to the midpoint 50.8 as the highest value, which is 45 frequency. In addition, the interval class between 22.6 to 35.31 equal to the midpoint 33.96 at the lowest value, which is 2 frequency. While for the interval class 55.32 to 38.03 and 28.04 to 30.75 as the lowest frequency, which is 3. That's all for me. I will pass to the next presentation.
Assalamualaikum and hi everyone. My name is Ros Ali binti Aris. My matrix number is A22A0114. I'm gonna continue this presentation on SPSS. SPSS is a software package used for statistical analysis. It offers a variety of tools for data analysis, modification, and visualization. SPSS is commonly used in social scientific research as well as in other sectors such as health, science, marketing, and business. I am going to discuss about numerical descriptive measures for weight for each vehicle per 1000 kg. Based on the table, the mean for the SPSS result is 3.89 less than manually, which is 3.90, with the difference 0.01. For median, the result in SPSS is 3.85 less than manually, which is 21.28, with the difference 17.43. The mode in SPSS is 3 less than manually, which is 4.14. The difference is 1.14. The standard deviation and variance for SPSS result are 0.5 and 0.25. The graph on the right side shows the data of weight for each vehicle per 1000 kg. Next, I'm going to discuss about hypothesis testing. The upper table is about ANOVA. ANOVA is a statistical procedure that pulls observed variance data from several components for future studies. A one-way ANOVA is utilized by 3 or more data classes to analyze the connection between dependent and independent variables. SPSS yields a significance level of 0.429 and an F statistic of 0.1000. The independent variables have discrete values and are categorical. Independent factors impact dependent variables. Let's move to the lower table, which is coefficients. Based on the unstandardized B in coefficient analysis, the weight is 0.059 and fuel consumption is negative 2.645. For the standardized coefficient beta, the weight is 0.008 while the fuel consumption is negative 0.951. The t-value for weight is 0.210 while the t-value for fuel consumption is negative 24.876.
Next, I'm Nur Adina binti Umar Zakir and my metric number is A22A0835. We'll continue part 5.3 correlation analysis. Based on the partial correlation analysis by using the SPSS, we had measured the determine the relationship and trend between the variables. A relationship occurs when change of one variable tend to be go along with by constant change in the other variables. During this study, we measured the correlation between fuel consumption, travel distance, and weight. Next, diagram on the right is a scattered plot metric. Graph 1 plot fuel consumption against weight. It seems that the higher the weight level we same goes to the higher fuel consumption. It seems that a strong positive correlation between fuel consumption and weight. Graph 2 plot fuel consumption against travel distance. In general, the higher fuel consumption will same goes the higher travel distance become. It seems that a strong positive correlation per fuel consumption and travel distance. Lastly, graph 3 of the travel distance plot against weight. In general, the higher the travel distance, the shorter the weight. It seems that a strong negative correlation between travel distance and weight. Next, 5.4 confidence interval. Confidence interval is a range of value within which the population parameter is supposed to exist. The 95% confidence interval can be related confidence level. Based on the result of the SPSS above, the lower boundaries and the upper boundaries are 15.79 and 16.98 respectively. Also, it represented the standard error for this dependent is 0.303, so it can be said that we are 95% confident the population parameter is between 50.79 and 16.98. Next, the last part is 5.5 prediction modeling. Test of normality. The Shapiro-Wilk test of normality on the residuals give a p-value is 0.001. Thus, the data significantly deviate from a normal distribution. For model summary, the R-square value is 0.894, which means 94.6% of the variation of price can be explained by weight and fuel consumption. The adjusted R-square is 89.3%. That's all from me.
Hi, I am Nur Izzati binti Muhammad Fazli. My number matric A22A0199. So, we go to the last slide, conclusion remarks. In conclusion, this statistical study was conducted carefully to obtain the true value of each data car brand. The random sampling used in this study is 150 observations from 393 car brand cases. From this sample, we successfully identified several factor studies. Several methods have been used to determine whether liters per 100, weight and kilometers per liter. The method used in numerical descriptive measurement, graphical representation, and statistical analysis using software SPSS. Therefore, the shape of the distribution is skewed to the left. SPSS shows a significant amount difference. The hypothesis testing revealed that at least one of the means was different from the others, with a significance level of 0.429 and an F statistics of 0.1000. The correlation analysis showed a strong positive correlation between fuel consumption and weight, with higher fuel consumption leading to higher travel distance. A strong negative correlation was observed between travel distance and weights.